is the square root of 5x squared plus 12x plus 9. This is step 2 in which I found my function. From this moment on, the rest is a piece of cake. So one more time. I didn't finish, but I just want to summarize. We drew the line. We know that somewhere on this line, there is a point that is the closest to the origin. All the other ones will be at a larger distance from the origin. There is one, just one, that is the closest. Okay. I picture it somewhere. It doesn't matter where, on the line. If the point is on the line, for any x value, the y-coordinate has to be the function. In this case, the line. I create a distance, which is the square root. And please do not try to simplify this. It's not simplifiable. You cannot take the square root from a sum. x2 minus x1 squared plus y2 minus y1 squared, and the square root on top. But since x1 and y1 are 0, this is not too difficult because I have for this, I have x squared. And for this, I have 2y plus 3 squared. I squared a binomial, I get a trinomial. The first term squared plus 2 times the first times the second, plus the second term squared. I cleaned it up. This is my function. So therefore, I know what I need to do next. What is our next step?
Differentiate.
Good, excellent. So f prime of x, please remember, is 1 over 2 the square root times the function prime. 10x plus 12. And when I eventually set this equal to 0 to find critical numbers, this cannot be 0, because if this is 0, then the distance is 0 is not possible. So nothing from the undefined situation. I get that x equals negative 12 over 10, and we simplify that as negative 6/5. So point A has negative 6/5, comma, f of negative 6/5, which is y equals 2 times negative 6/5 plus 3. So what does this equal to? Negative 12 over 5 plus 15. So negative, so it's 3/5. So y equals 3/5, 3/5. So now I know for sure. Of course, that was not the point. The point has coordinates negative 6/5. As expected, exactly where this is perpendicular, as it should be. So that's where the point is. And the coordinates are these. Now, do I know that this is minimum? No, I don't yet. It takes another blink to show that. Please always show, do not assume. So 0 to the maximum cannot be more than, oh, actually, I have to write negative infinity to infinity. Okay, so this is negative 6/5 and 0 here. And I'm looking at the function. I will not plug in anything here. It's all positive. To the left, so when I have, to the right, when I have 0 is positive. To the left, when I have negative 10 is negative. So this is definitely the smallest. If I'm asked to find the distance, in the function I have to plug in negative 6/5. In the distance function, in here, this is the distance function. In here, let's plug it in. So I have in y equals, I have the square root, where's my square root? Okay, square root of 5x squared. I prefer this, you can say, but it's only one number. Why do you have to punch in the function? It's easier for me to see it, and maybe, who knows, maybe I want to punch it into something else in there. But I understand. Oh. See? See? I talk too much. That's what it is. Okay. So when I plug in -6/5, I get the distance. And the distance is 1.34164. 1.34164. In case I'm asked to find the distance, this is the number here. Everything else, any other point, will be found from the zero from the origin at a longer or higher distance. This is the shortest, where this point is. That's optimization. I know we have 6-7 minutes left, so let's at least start another problem, or this is the end of chapter 4. And chapter 4. You can say, what about 4.9? 4.9 should be in chapter 5, and we'll start with it, and it's part of the last test. So 4.9 does not belong in this chapter. Okay, so let's at least start another problem. Okay. So here it is, one in which the function is given. So maybe we can finish it. We're given, if a resistor, so this is 51 on 345. So R is measured in ohms, is connected across a battery of E volts, okay, with internal resistance of R, also in ohms. Then the power in watts, the power is of the external resistor. So the formula is given to us, the function is given to us. E squared R over R plus R squared, where E and R are fixed. This is the variable. What is the maximum value of the power? So this should be P of R, to be exact. E squared R over R plus R squared. These are constants. This is a constant, and this is a constant. They want us to find R to maximize the power. So there is no need for figure. There is no need for finding a function. We are going directly to step 3. What is step 3? So step 1 and step 2 are not necessary here. We go directly to step 3. What is step 3? Yes, P prime of R. This is a constant. Please leave it alone because this is a factor and nothing else follows. Top function prime is 1 times the denominator minus the top times the denominator prime, where this is fixed, is a number, 2 R plus R to 2 minus 1 times the inner function prime, which is 1, and this is 0. Everything divided by R plus R to the 4th, of course. Remember, factor and simplify. Always, always, please. So, of course, I will factor out what?
R plus R.
Of course, thank you very much. So E squared stays in front. So R plus R come out. Now I can remove one of them. So I took one out, but there is one left. I took this out, so I have negative 2r. Good. So finally, I have e squared. Negative 2r plus r will be negative r plus r divided by r plus r to the third. As you know, I am allergic to negative leading coefficients. So p prime of r equals 0. Of course, r must equal r. There is nothing else. Does this give a max? Who knows? I have no idea. Okay, R is so these are resistors, so we cannot, nothing can be 0 or negative, right? So this is positive, this is positive, so I will not even worry about it. So I have negative R plus R. So if I replace this by 0, I have negative times negative, which is positive. If I replace this by 10R, 10r minus r will be 9r, but there is a negative in front. Typical for a maximum. If I need to determine it, okay, P of r, e squared times little r over little r plus little r, 2r squared, 4r squared. And that is the maximum.